And welcome to the Daily Space Weather. We've got a CME watch in effect. Ionospheric anomalies, composite imagery, new sunspots, weak solar activity. Is it the calm before the storm? It indeed is. Here's our composite imagery. It's 171 angstroms and the magnetogram to show you two new sunspot groups forming. One of them is right here, almost right in the center of the Earth-facing portion of the solar disk. The other one is down here. It's a triple umbra. Those are both beta-class sunspot groups likely to get names today. Sunspots 2851 and Sunspot 2852. 2851 and 2852 there. Here's a full disk view in ionized helium and 171 angstroms ionized iron. This could be my new favorite composite wavelength. Let us know in the comments what you think. Fantastic imagery here from the Solar Dynamics Observatory. Here's a close-up of the first one to show umbrae. This should be Sunspot 2851. It'll be named today. It's been there since yesterday's video. And here's likely Sunspot 2852. This one's a little bit newer. And it's right up here, suddenly forming there, just above our Earth scale. Here's a star chart if you're wondering where things are above your head. Check in-the-sky.org, put in your location. I've drawn on the ecliptic. You can see Jupiter and Saturn, as well as the moon up there if you're up before dawn. Here's a diagram of the solar system. Keep in mind, this is not to scale. We've advanced that 1 week. There's where things will be in 1 week. As Mercury is catching up to Venus, and Venus is catching up to Earth, and Earth is swinging past Jupiter, having made it past Saturn. 10.7 centimeter radial flux all the way down to solar minimum conditions at 71. Solar flux units, check it out. It's the calm before the storm, folks. The 10.7 centimeter radial flux is the most proportional data set to sunspot number. Here it is in the black line. That's the 1-year chart from solon.info. And here is the red line below it. That's the sunspot number. Looking weak in terms of solar activity. Again, radial flux down to 71 solar flux units. And we are expecting a geomagnetic unrest period early in the day tomorrow on August 6th as a result of North Pole-oriented coronal holes. And we're talking about this one up here. And in a few days, we can expect some geo-affect from this series of coronal holes in the south. By the way, this is composite imagery in 193 and 211 angstroms, also from the SDO, the Solar Dynamics Observatory. Just splentacular imagery there. Next, let's look at seismicity. Current seismicity level is moderate. That's the 90-day graph. And you can see that 8 magnitude quake ending the long drought of 7+ magnitude earthquakes. And we're getting another swarm here south of the Alaskan Peninsula. Those are all small in magnitude. And we saw a deep quake event yesterday. Let's see if we're seeing more deep quakes now. Starting out the list of the past 24 hours, there's a 4.6 in Indonesia at depth, nearly 170 kilometers. Another deep quake at Afghanistan, a 4.9 at 144 kilometers. There's a deep quake in the interior of Alaska. It's only a 2.9 magnitude, but over 100 kilometers depth. One of the largest of the past 24 was this 5.5 east of India. Taiwan saw a 5. Oh, there's the largest quake of the past 24. I think was a 5.8 at Taiwan. Let's take a quick look at the location of that. Here's the interactive map just off the northeastern coast there of Taiwan. Likely felt at Taipei, going back to the list. And if we leave anything out, just leave us a comment. In fact, leave us a comment regardless. Deep quake at Tajikistan, a deep quake at Indonesia. Tajikistan quake at a 4.2 magnitude, 122 kilometers depth. Indonesian quake 5.3 magnitude, 527 kilometers depth. That's a little bit deeper than human drills are able to go. Also a deep quake at Fiji. So 2 days of deep quakes here documented. Let's check volcanoes. And we see a bit of an uptick here in volcanoes as well. Karimsky, as seen in this image here, visible from quite a distance from the Uzon caldera on August 4th, yesterday. Mount Abico exploding, 12,000 foot ash plume over Abico. Subanosejima, flight level 070, 7,000 foot ash plume over the Ryukyu Islands. Luitolo, the volcano of the Lesser Sunda Islands, exploding, flight level 080, 8,000 foot ash plume there. Samisa Pochnoi in the Aleutian Islands, exploding as well, 10,000 foot ash plume. Now Pacaya back on the list as a new eruptive phase has started in Guatemala. So that's about a 12,000 foot ash plume produced there. Also volcanic tremors. The McKinney Summit crater's morphology changed since the last eruptive phase as slag cones and lava flows have destroyed and filled up its interior. With 100 meters depth, emissions of steam and ash continue to emit from the crater. In Ecuador, we've got Sangay and Revenador producing 19,000 and 16,000 foot ash plumes respectively as both of those volcanoes explode. In Peru, we see Sabancaya exploding, 25,000 foot ash plume there. Nevados de Chilean exploding, producing a 15,000 foot ash plume over central Chile. A stark reminder to please not pole vault the caldera. You're not Steve Stimpak after all. Steve Stimpak passed away in a tragic table tennis accident after attempting to advance his career. This public service message brought to you at massive personal risk and expense by smashamash.com and youtube.com/smashamash. YouTube is not responsible for this public service message. It's just from us. No major solar flares over the past 24 hours, or the past 3 days, really. And the likelihood of solar flares goes up, especially if those sunspots continue to grow, the ones we documented at the beginning of the video. Proton flux, no spikes there, and we don't expect any. No coronal mass ejections headed our way. Goes magnetometer. Over the past 3 days there, getting into a little bit more normal levels here, and looking pretty smooth. But it's not going to be smooth for long, as there's a coronal hole wind stream on the way, and we're seeing very low solar wind, so we're going to see some big spikes in all of the data in the next 24 hours. So here's the top view ecliptic plane field plot showing you the polarity of the heliospheric current sheet. As we stated yesterday, the North Pole current sheet is approaching. You can see it here in green. It's just about to reach stereo A. And here's the line of sight view of the same data. It shows you a three-dimensional view of the heliospheric current sheet's polarity. And here's the line of sight coronal hole plot showing you the sun's B field in blue. And you can see those South Pole oriented coronal holes. The North Pole oriented coronal hole that's already nearly sent its high-speed coronal hole wind stream to Earth, not even showing up here on the data. So as we showed earlier, there's a coronal hole right here, North Pole oriented as well. For some reason not showing up there. Here's the latest image, and you can see the size and breadth of that South Pole oriented coronal hole system. Should be providing some significant high-speed wind. Here's the solar flare monitor and the detected sunspot groups. I would expect this to get named 2851 and this to get named 2852, but for some reason the detection is picking up the Earth-facing one and not the one near the limb. Whatever. Likelihood of solar flares goes up when we see umbre. KP index, a measurement of global geomagnetism here, pegged at 0 for the past 15 hours, each one of those bars representing 3 hours. Again, very low induced magnetism from incoming solar protons. Let's take a look at the real-time solar wind to show you how low it is. Solar wind speed below 300 kilometers per second, only 289 kilometers per second there, as we see a little bit of a break in solar output with some solar minimum conditions here as solar cycle 25 ramps up. Density only 6.78 protons per cubic centimeter. Not excessively low for the density, but excessively low for the speed. It's even kind of cold, as you see on this bottom frame here. Warming up a little bit as we await the sudden spike in the solar wind density, indicating the onset of the coronal hole wind stream. Geospace magnetosphere movies are down for a second day in a row. We tried to load them, but it didn't work. It's probably because there's missing data in the space weather modeling framework. That was more than we saw when we did show prep. Next, ground magnetic perturbations, and the same thing. These are based on the same sets of data. And let's talk about geomagnetism for a quick moment. I've been saying things that aren't true on the channel, and let me just take a moment to apologize for that. Earth doesn't really have two geomagnetic north poles. That is insane, as Eugene pointed out. So watch our video from yesterday, Geomagnetic Mayhem. Eugene and Smash square off. Who's the geomagnetic jerk? Anyway, it's a good video if you want to learn about geomagnetism, Earth magnetism, space magnetism, and so on. Magnetism, magnetism, magnetism. Hopefully our channel's magnetic. Congratulations on realizing it exists. Thanks for viewing the videos. Tell your friends and foes we don't think the algorithms like us. We're also on Twitch. We regularly stream there. We'll be doing our meteorology segment from there. We're also on BitChute. There's exclusive content. Look for more coming soon at BitChute. Today's cosmology segment will be short and sweet. It will feature no random numbers. I just wanted to show you Cygnus X1. So this is the first object widely believed to be a black hole. I'll call it a massive radio source. Famously bet on by Carl Sagan. Famously betted on by Carl Sagan and Stephen Hawking. Cygnus X1 is the massive radio source located pretty close. I think this one's only about 1,600 light years. Correct me if I'm wrong. About 1,600 light years. And I just wanted to look briefly at the cyclicity here. So on this 16-year graph, you can see how it's got this slightly higher X-ray state and then this slightly lower X-ray state. And you can see it sort of fluctuates between those two higher and lower states. They're looking pretty similar there. Does this give us insight into the physics of what this massive radio source is up to? Well, I don't know, but let's take a look at it in some different spectra here. Cygnus X1, one of the many interesting things in the constellation Cygnus. So I just wanted to bring this up briefly. This is the Finkbeiner hydrogen alpha imagery. So what you're looking at here is really a void. A void. Is that void created by Cygnus X1? Or is it just a coincidence that it's there? I'm not going to conjecture about it, but we do see a dark spot there. Less hydrogen gas associated with that object. When you look at it on pan-stars, you can see how far zoomed out we are. And there is a void region, possibly carved out by this object. But anyway, there it is in optical. The pan-stars survey is quite high resolution and includes quite a lot of the sky. Let's look at it on the 2-mass. Here it is in the infrared spectra, and you can see it's quite hot around Cygnus X1. There's light from it. Some people believe it's a black hole. We'll just refer to it as a massive radio source. Moving on to invite all of you viewers to join us on our own website, smashomash.com. Smashomash.org will redirect you. Check out our social media, maybe become a patron. Check out our forum. If you click on SMASHO merch, you'll find today's featured product, which is Make America Not Suck Again, Mansa. And I'm actually wearing a shirt right now. This is the purple Mansa shirt. It's completely nonpartisan. It's not anti or pro-Trump. It's not anti or pro-Biden. It's not Democrat. It's not Republican. It's not Libertarian. It's not a political hack, period. Make America Not Suck Again, because it's up to you, not the government, not corporations, not Dr. Fauci, not anybody besides you individual people. So pick up some merch and tell your friends and foes about it. We've also got the Mensa for you international viewers. Make Earth Not Suck Again. And thanks to Free Life Tasmania, as we've got some products on the way to Tasmania, yes. So these will ship internationally. Mensa, Make Earth Not Suck Again. It's up to you, not the European Union, not the UK government, and certainly not the WHO, CDC, etc. Make Earth Not Suck Again. It's up to you. help us help you by picking up some merch. Links at smashomash.com, smashomash.org will redirect you to our homepage. Today's astronomy picture of the day is some moon craters. I'm fairly uninterested in this, but we show the astronomy picture of the day regularly, maybe not every day. It's Tycho and Clavius. And I'll just let that scroll there so you can see the caption. Feel free to pause the video. You can find the astronomy picture of the day at apod.nasa.gov. That's today's cosmology segment. It's integrated into the daily space weather video, and if you've never seen one before, check our playlists, youtube.com/smashomash/playlists. There are over 200 cosmology segments as separate videos on the playlist. Next, going back to Earth's environs here to see no charging hazards. We did get into warning levels yesterday for electron flux. Let's take a look at it first. The 1-year chart from Solon.info. Solon.info/solar, the greater than 2 mega electron volt electron fluence. Relativistic electrons surrounding planet Earth. It looks like we're creeping back into warning levels again today. We briefly touched on 1,000 pulse flux units, or 1,000 particles per negative second squared. Anyway, that's the 3-day chart of the electron flux, as measured by the GOES-16, and by the way, this measurement is taken at the Ionosphere layer, which is located at about 300 kilometers of altitude, the bridge between Earth and space. Here is the forecast model from NOAA. And NOAA forecasting slightly lower levels here. I would forecast, I don't know, I don't have a forecast. I'll just leave it at that. The green boxes are the forecast, the yellow diamonds are the observations. Here's a diagram of Earth's Van Allen belts. We show it daily just to orient people as to what we're looking at. And now we're looking at the total electron content. This will give you an idea of where GPS errors are likely to occur. Thanks, Ricky, for commenting yesterday about GPS errors. By the way, viewers, if you turn on location accuracy, especially if you're around the equator at noontime, your smartphone will use Wi-Fi signals to make it much more accurate to detect your location. When GPS alone isn't giving you the data, it might help. And we've documented massive GPS errors on our Instagram page, instagram.com/smashomash, if you haven't checked us out over there. There's lots of exclusive content on Instagram. Despite it being a Facebook property, we still use it, even though Facebook software is absolutely some of the most pathetic on the entire internet. Anyway, things looking pretty normal here in terms of locations of electron densities. Next, we'll look at the ionosphere, and we're seeing some major anomalies here. And when we look at the ionosphere, we're looking at the F layer located here at 300 kilometers of altitude, the bridge between Earth and space. And let's just reload those. And we're seeing major anomalies here. So I'm just going to let this one play and check out the sudden high charge ups here over the Caribbean, making it all the way up to 14 megahertz there. That's the highest vibrational frequency we've documented in quite a while here on the Daily Space Weather videos. And you're looking at the full day of data here. So Central Atlantic Ocean seeing some major ionospheric anomalies over it. Also around the North Pole. And the next frame will actually show anomalies in megahertz. So first we'll bring up the latest image. That's from 9:30 Universal Time. You can see the anomalies there around the North Polar region. And here is the anomaly animation. And this is showing you low frequency anomalies in red, high frequency anomalies in blue. Lower than normal vibrational frequency in red, higher than normal vibrational frequency in blue. And this is based on the 30-day median. Anyway, Western Hemisphere seeing some significant anomalies here. They look like they're centered around the South Atlantic anomaly, which is now over the South American continent. And anyway, there's the latest image from 9:30 Universal Time. And again, we're going to do a meteorology segment today. Make sure you check that out. It'll be a separate video. And here come bonus features, starting with Lermonth, Australia's ground-based solar observatory. Quite a bit of filaments here on the Earth-facing portion of the sun. There's a bit of plasma suspended between the Earth and the sun. That's why we have a CME watch-in effect. Also, as those sunspots grow, if they continue to grow, Likelihood of solar flares goes up, obviously. Here's your GOES 16 SUVI map. And you can see all those filaments mainly in the northern hemisphere as shown by this, but there are some in the south as well. Next, thanks to our patrons, the true source of funding for the content. Please consider becoming a patron and increasing the probability that these videos will continue to exist, remain publicly visible, and free for all to view. Patreon.com/smAshomash. Our patrons get all sorts of perks nobody else gets, early warnings, etc., as well as astrophysics data, information about our science paper writing, and so on. Thanks again, patrons. And there's what we saw when we did show prep. 3 umbrae associated with likely sunspot 2851. Let's press refresh. And press refresh on the colorized magnetogram as well. So here's likely sunspot 2852. Not looking particularly strong there. And here's likely sunspot 2851. There are the fields. You can see it's beta class. That one's beta class. That one's actually looking a little bit more defined there. You can see how well defined the magnetic fields are. Although it is right in the Earth-facing zone, so the likelihood of major flares out of that sunspot are quite low. Here's one of my new favorites. This is the 335 and 171 angstroms composite. Those are both iron, ionized iron ultraviolet emission spectra. And thanks everybody who tuned into the Daily Space Weather video. Please tell your friends and foes about the channel. And may that solar wind be at your back.